Hello friends, welcome back to the bench. Thank you very much for joining me. Our patient is an X670E with AM5 socket, which looks, by the looks of it, it looks like the CPU dropped on it, destroying the socket. In which case, the only solution is to replace the socket. We got two big gashes over here and some damage over here, so the socket is unrecoverable. If you have this issue, you can send the board to me. Doesn't come with testing or anything like that, but it costs only 50 bucks shipping and cost of the socket included. So it's pretty much basically a free repair. Now, not a day goes by if without someone reaching out to me asking about this procedure and reporting their failures. And those failures are relatively easy to avoid if you just follow the procedure correctly. IR6500 rework station is around, you can get it for maybe $350, below $400. On top of that, you might want to spend 10 bucks for my software, which makes it a lot easier to perform this operation. But obviously, you also it's good if you modify your rework station to remove the bottom plate and pull the thermocouple so it touches the bottom of the board. I'll show it to you in just a second. But even without that, this procedure can be performed on the stock version of the IR6500. The way the thermal feedback works on this machine is the thermocouple needs to be placed somewhere close to the socket. In addition, it also needs to touch the board at all times. So problem number one that you're going to face is the thermocouple detaching from the board. So very important to place it correctly. Now, in addition to that, as you can see, I have few loops over here, which holds it a lot better. And as you can see, as long as it's held over here, it will spring down to the board. Even if you release a little bit of tension on this side, it will still be touching the board because it's bent a little to always touch the board. But for that to have a desired effect, the board needs to be clean. And as we can see, we have dust over here. So this needs to be cleaned so the Kapton tape adheres properly. Now the board is clean, but before we start attaching the thermocouple, if you use Rework Pro, this will be easy to observe. So the blue line in Rework Pro will indicate the set point. So we might have a profile like this. Right, and this will be the stop. Right, say there's 160 over here and maybe 245 over here. The red line will indicate the actual temperature. So the actual temperature will be lagging a little bit behind, but it must follow the blue line exactly. And this is what it's supposed to look like. Now, if you're observing that the temperatures are looking like this, the thermocouple is not attached correctly. It is either not in the right place, it is either not touching the board, or perhaps it's on the other side of the board, or perhaps it is covered by the Kapton tape. We might observe a little overshot over here. This means pretty much the same thing, but even if this is stable and you experience overshot over here, that's not good. Something's wrong with the thermocouple, probably positioning. And likewise, if the temperatures are lagging, so we're going like this, you will notice that the blue line will never go too far ahead of the red line. So it'll look like this. That means we're heating slowly. This might mean that the board is very thick. It might mean that your top heater is not powerful enough to work with whatever you're working with. But typically, if our profile is here, right, the actual procedure will lag behind a little bit because the board is not going to heat up as quickly as the set point is growing. And if you set your temperatures, if you're ramping to say 0.8 or above, the board will most likely not be able to heat up this quickly. So this is normal if your procedure takes longer. There is an estimate on the profile in Rework Pro that tells you that the profile should take roughly, say, 15 minutes, but it actually takes 25. This is normal. Don't be alarmed by that. So first decision we need to make is where to place a thermocouple. Now each board is going to be different, and in some boards you're going to notice that half of the socket is already loose, it's already ready to come out, but the other half is holding firmly. Now if you get tempted and you pull a bit too hard, you're going to rip some pods. And the sockets should come off with no resistance, especially if you use flux. And if that happens, you might just drown it in flux, and that might help. But the reason behind this is that the board is always going to have a lot more copper on one side. If you experience the problem of half of the socket being desoldered and the other half staying firm on the board, that happens because we have different amount of copper on each side of the socket. There's going to be a lot of copper coming from the V-core. There's going to be, as you can see, the top layer over here. This is all copper plane here. All of this is copper. Typically on this side we usually have less copper than on this side because we're grabbing a lot of current from V-core. But as you can see on this board, we have plenty of copper on this side. So based on that, you may need to adjust the center position of the top heater. Typically, the top heater will be placed in the center of the socket. That is a good rule to have. But sometimes you may need to adjust based on what you see. If you see that this side, this whole half is loose and this half is not coming out, that's normal because this half has the majority of the power. So there's going to be a lot of ground pins on this side, fewer ground pins on this side, which will make it easier to lift this side as opposed to that side. If you try to pull, like work against it, you're going to rip some pods. So don't do that. If it's not coming up, just leave it be. So sometimes what I do is I move the heater a little bit to the back. I also had issues where this side of the socket soldered perfectly and this one was lifting. After resoldering, it's good to just gently pull on each corner and gently press in each corner to confirm that the socket is not moving. If it's not soldered on correctly, it will be moving. And I've had situations where this half of the socket was not soldered on. But that's pretty simple to overcome, to correct, because you just move the heater up, maybe here, so the center would be roughly here, and reflow it again, and it should resolder. Obviously use plenty of flux. So the first decision we need to make is where do we place the thermocouple. We don't want the thermocouple to be too close to the hole. We want it to be close to the socket but not touch the socket. It cannot be in our way. And the way it is positioned, we want it to stay on the board throughout the entire procedure. So removal of the socket, cleaning of the board, and replacing the new socket. We want the thermocouple to stay in place for the entirety of this procedure. So for that reason, it needs to be placed very firmly, and it needs to be placed strategically. So this is what it looks like. Plenty of strips of Kapton tape all around. The more the better. Because the worst thing that can happen to you is the Kapton tape coming off and the thermocouple detaching during the procedure. It's a pain and there's no way to recover from it. We just have to start over. Now what I used in addition is the second thermocouple placed on the opposite side of the socket. This thermocouple is not involved in the process. It doesn't communicate with the software or with the machine. It just gives me the ability to see the other side, the temperature of the other side of the socket. And I like to see those two temperatures close. But again, this one also needs to touch the board, otherwise it's going to be throwing you off. But if this one detaches, that's no big deal. Okay, we have both thermocouples placed. Now this one is a little bit too close to the hole. If it was a primary thermocouple, this would be too close to the hole. The reason behind is that through this hole, a lot of energy emits from the bottom heater, and it might give the thermocouple a false positive. The temperature is not actually as high as the thermocouple registers. We wanted the primary thermocouple. We wanted at least a centimeter away from all the holes and just a few millimeters away from the socket, just so it's not in our way, but as close as possible. Now this could be a little closer. We could move it a little closer, but again, you don't want it to mess up with your process or interfere with your process, to mess with your process. Now we need to cover the caps and the memory, and we'll cover this as well. Basically all the plastic components, because there's going to be a lot of heat. And it's not because they will melt, because we're not going to reach melting temperatures of these plastics, but this is plastic and metal. In high temperatures, plastic and metals expand at different rates. That potentially can cause issues with the memory, basically deformation. So for that reason, we want to cover the slots very well. But one thing that I noticed is that if you put this tape directly on the memory slots, this glue is going to stick to it very well, and it's going to be very tough to clean it. So for that reason, I use something else. A regular aluminum foil. This is the thickest kind, or one of the thickest kinds I can find. And there we have it. I messed up a little bit over here. So we have a part of the socket hanging from here, but that's fine. It's pretty far away from the socket. This will be fine, but just for the heck of it, I can just correct it like this, and now it's perfectly covered. Now this needs to be low because the side camera is looking from this side, and we want to see, so we don't want this to obstruct our vision. And the rest, make sure to cover the caps. Now if you do the procedure correctly, you don't need to cover the caps because you're not reaching the temperatures that explode the caps. But it's always good to cover them because it also impacts now they're aging. You don't want to expose them to too much heat. But if your cups are exploding, and this is common reporting I hear from you guys, if your cups are exploding, the temperature is too high. If the socket is melting, the temperature is too high. If the board is bubbling, the temperature is too high. And the temperature will be too high if the machine is unable to read the temperature correctly. The PID loop in this machine has pretty high I, pretty high P, and relatively huge D. So that means it reacts quickly. The machine we're working on will give you the ability to adjust those parameters. In IR6500, there's no way to adjust them. You just have to live with them. So for that reason, the thermocouple placement is the most important part of this procedure. And in addition, as a general rule, the more time you spend prepping, the better the results you'll have. And this is actually something that I received in the comment as a suggestion based on my initial work and my initial results which were not too good. And someone told me exactly that. I applied it and I have a lot better results, and the procedure is a lot more satisfying because it works. As far as the mods to the machine, as you can see, the bottom plate is off. The thermocouple is just hanging in the air over here. I'll just push it like this, and as I place the board, the thermocouple touches the bottom of the board. That's where we read the temperature. In addition, I also put some angle brackets over here and wrapped aluminum foil around in hopes to keep this temperature in here a little better. Reduce the amount of draft on the bottom heater. Now, I haven't picked the perfect weather for this today, so there might be some issues. Humidity is relatively high outside and it's a little chilly. So this might pose a problem. It is very important to keep the climate of the shop conducive to this job, to this procedure. The temperature of the shop and the humidity, basically the atmosphere in the shop, can have a huge impact on the results. So also be aware of that. Now, what's new in Rework Pro 109? As you can see, we now read the bed temperature. That is the second input of the machine, the address, the zone B address, which can be adjusted. You can also change the zone A address, which is the top heater. You have to make sure you are disconnected from the machine before changing the address. Okay, now that we have everything ready, let's select the profile. So as you can see, for sockets like AM5 or 1151, we have two profiles, one for removal and one for replacement. The removal gives you a little bit of a little higher temperature and a little bit more room to remove the socket. This profile should take 12 minutes and 44 seconds, but obviously it will take a little longer. Now the removal of 1151, as you can see, the difference is just that it will hold the top temperature a little longer, and you just need to stop the program yourself, stop the profile yourself. Now let's review. This is for 1151, 245. That is perfectly enough for AM5 as well. And we're holding for 160 seconds. We ramp up to 120, or to 160, sorry. 160 for 120 seconds, and 225 and 245. So I'm gonna modify it. I'm gonna remove this process, or this step, and this step at 235. We don't want to hold it for this long. Let's hold it for 30 seconds. The board is going to be well preheated, so 160 is going to be close to what the preheating temperature will be. So let's hold over here for 30 seconds, then another 30 seconds on 235. That'll get the socket nice and toasty. And then ramp up with 0.5 degrees per second to 245, and we hold it for a while. So that's our new process now, our new profile now. But before we get there, first, on the machine, we need to set the proper temperature on the racks because the software is not controlling the bottom heater yet. I set it to 200 degrees. That should be more than enough. That will give us roughly 140 to 160 degrees on the top. Once we reach that temperature and we stabilize, that's when we start the procedure. Once the temperature on the racks is set to whatever we want to set it to, we hit the preheat button. Okay, I had to rebuild the solution because it wasn't connecting, and the version I had installed on this one was a little earlier version, and it has an issue which causes the machine to just kind of respond with the delay. So you click the button and a few seconds later the action happens. So again, first we just want to preheat to the set temperature. So we're gonna hit the preheat, and the machine is gonna start preheating the board, and we're gonna observe the red line going up, and once it stabilizes we should see roughly 140, maybe 150 on both thermocouples. Okay, so here we have a first hurdle. As you can see, the 10-minute preheating phase has completed, and our temperature is 121 degrees. It's a little bit low. Our bed temperature rose to 171. Now we could give it another round of preheating, which probably is what we should do, and the reason is because it's cold. It's a little chillier. So don't follow the procedure exactly the same way regardless of the environment. Sometimes you need to adjust the procedure to the environment. Also note that the second thermocouple detached from the board, and you can see the difference it makes. First of all, it's fluctuating and it's showing the temperature lower by 40-45 degrees than the temperature of the board. That's why if your main thermocouple detaches, that's gonna impact the temperature of the heater and explode your cups, melt the socket, destroy the board. Okay, we're roughly at 130, 140. That should be well enough. The temperature doesn't seem to be growing anymore, and you see the red line being a little choppy. That's a bad sign because we're experiencing the temperature that is not stable. That usually means that there's a little bit of draft, the thermocouple is exposed to that little draft and it affects the temperature. This is not hugely choppy. This is relatively fine. Not perfect, but it's fine. If your fluctuation is, say, by 10 degrees, then the procedure is not going to work. The board is going to be damaged. So let's stop the preheating and let's start the procedure. Hit start and let's do it. We're at the temperature where you can see the socket is lifting a little bit, right? But it's still giving us some resistance. So don't be tempted to just force it up. It'll come up as soon as it's ready. Give it a little lift here, a little lift there. See which corner is giving you the most resistance. Very gently and very slowly. And there we have it. Alright, no flux, no nothing. We don't want to see any pods being pulled on the other side. Now, the fun stuff. Definitely use a... Okay, let's stop the machine and hit the preheat button. So now we just want to keep the bottom temperature. So first step, we need soldering iron. Any flux. I use, for this, just pretty much any flux because it doesn't matter. This is NC, Amtech NC. And just get a lot of it there. Just drown it in flux. Then soldering iron. Definitely use a fume extractor if you have it. If not, make sure you have good ventilation in the shop. And what we want to do is just put a little bit of solder here to create a nice little bowl. And move that bowl around until it grabs all the solder from the board. And then you just remove that little bowl and then start wicking. From there, remove the flux with paper towel. Always mind that the heater is hot, so when you move it out of the way, don't keep it over anything other than the socket, and because it'll burn, especially plastic parts. Keep that in mind. Next, a good King Bowflex RMA, generous amount, and a wick. Now clean the solder again. Now this step is very important because if you leave a little bit of solder on the socket, on the pads, the socket alignment will be very difficult, if not impossible. Once the socket or the pads are clean, we are ready to place the socket. So what I use is a flashlight, so I can shine it from each direction, and a nice head magnifier so I can see. Now, first, generous amount of flux at the bottom. Then open the socket, check the pins, because you don't want to discover afterwards that the socket was damaged. Place some flux on the socket. If the board was clean, the socket should slide across the board with no resistance. If it gives you resistance, you need to remove it and clean the pads again. Okay, socket is aligned. Be very patient with this. This is the step that took me the longest to properly align the socket. It seems very simple, but it's a lot harder in real life than it is in theory. You can trust me on that. So be patient with the socket alignment. Alright, and that's it. Now we just need to run the resoldering profile. So let's load. We don't need 160, do we? What's the temperature now? 130. So 160, let's just do 10 seconds. Then 225 reflow. This is where the flux is going to start burning. So let's keep it for 10 seconds. And then 235. 235 should be enough, but I'm going to go to 240 just to be sure it's not going to burn. And 60 seconds will likely be too much, so I may just stop the machine before it actually finishes. And start it. And that's it. The socket should be replaced. Now keep your eye on the socket and you will see the moment it drops. It should drop uniformly, not one side first and the other side. It should drop uniformly. It's we'll see. At 225 probably it will drop. It depends on a lot of factors, one being the socket. You get different kinds of sockets with tin balls, with some leaded balls. You get different kinds of boards that react differently to heat. So it's not a golden rule to know at which temperature the socket will drop. You just need to observe it. Alright, I missed the moment where the socket dropped, but it definitely dropped. I can see it now. And as you can see, it aligned itself, right? If it's slightly misaligned, and we're talking about the fractions of a millimeter, it will align itself. But if it's misaligned by more than a millimeter, it will not. It will actually not work. Okay, so at this point, let's stop it, because it definitely soldered on. Lift the nozzle and allow it to cool down slowly. Don't remove the board yet, because it might potentially cause the damage to the board, the rapid changes in temperature. Don't start the ventilation yet. Don't blow on the board. Alright, the board cooled off. We are at roughly 50 degrees, so I'm gonna remove it shortly. But one thing that I forgot to mention, and I got lucky, I did not check the position of the bottom thermocouple. Now, why is that important? One time it happened that my bottom thermocouple just was sticking through the hole in the board. That means it wasn't reading the temperature correctly from the bottom, which resulted in board overheating. Board was just on the way higher temperature than it's supposed to be, which is not good for the board. Some people recommend heating it up to about 200, 220 degrees. I have 200 set on the bottom heater, but it never gets to 200. It gets to closer to 170. And that's roughly the temperature that I like to keep on the bottom of the board. But every board is different, and for the sockets it works pretty well, but for BGAs, like the big chips, maybe GPU, that temperature may need to be increased. Now from here we're gonna wait a little longer to let it cool off. The heater is just slightly warm, which means now I can safely move it to the side without risking anything burning. And while the board is still hot, it's easier to remove the foil. The foil will leave a lot of nasty residue. Unfortunately, that is the reality of it. Nothing we can do with that. But the ultrasonic cleaner will remove the majority of it, and then you just need to work with alcohol and the swab. Note that my main thermocouple remained adhered at all times. It hasn't moved, so that's the proper installation of the thermocouple. Very important step, absolutely crucial for this entire process. Now the socket is nice and solid everywhere. It looks perfectly aligned. It looks perfectly flat. It should be a successful replacement. Now from here, just let it cool down, and into the ultrasonic cleaner it goes. And there we have it, nice and easy. It really, once you do it, say 10 times, maybe 20 times, it's not as hard as it is the first time around. Now, I always say to whoever is starting, as I see the problems as they are encountering, I always say get the 10 boards, and every single one of those 10 boards you're gonna destroy. But it's important that you don't destroy any one of those boards the same way. With every job you need to learn something, and there's no other way to achieve confidence in this repair than to just try it multiple times and fail in multiple ways. That way you can avoid problems as you see them, because you know how to fail. That's the only way to know how to succeed. Alright fellas, thank you very much for watching. I hope you found this little tutorial helpful. The board is going back to the customer. This is a free socket replacement. If you're in need of such a repair, ship the board over to me. I charge you $50, and that covers everything: the replacement, the socket, and the shipping. Thank you guys again for watching. I do appreciate you, and I shall see you in the next one.